Okay, we are going to solve this one, the 26 one, that I think some people are having troubles. Okay, and this 26 one, it says that it gives us a triangle ABC, and this triangle forms like a pyramid with a point D, which is a common vertex. Yeah, define a point D, which is the question they're asking us to define point D such that the slope of the planes BCD, ACD, and ABD maintain the proportion BCD, ABD, and ACD of 1, 2, and 3 respectively. Yes? And then it says that if the distance from D to the plane ABC is 100, the slope of BCD is, so that's the question. Yeah? So there is well, different methods to solve this, and then we are gonna check here. Okay, so we have this triangle. Yes, so it should be ACB. Yes, so it should be ACB. Yep. So then we have, I'm gonna solve it in two different ways. Yeah, so I'm gonna write here solution one, and this is going to be for me like the most intuitive way. Yeah, so first thing is we build the point D, and we don't know exactly where it's going to be and anything, but what we do know is that the height of this point is 100. So the height is the distance with the horizontal plane, or la planta in this case. So we said that this point is on top plane, this is perpendicular to the top plane or to the horizontal plane, as you prefer. And then we need to say that this is 100. Yeah. Okay. So we can still move this point, and you see that by moving it, we have different slopes on the different planes. Yeah. So the one method to solve it, which is relatively intuitive, is to build the slopes here apart. Yes. So I'm gonna double click on the horizontal plane, and then I'm gonna make a circle. Yes, I'm gonna make a circle. I'm gonna fix this point so I cannot move the circle. Yeah, and I'm gonna make here a cone with all the different slopes. Yes. So this line is a vertical line, and then I'm gonna build all the cones. So for example, if this is the slope, for example, ABD, yeah, so on this side of the cone parallel to this one, I'm gonna make the ABD slope. Yeah. Yeah, but now before that I need to do something. I need to check the slopes. Yeah, so I'm gonna segment this vertical line. I'm gonna segment it in three segments, or instead of 3 segments, in 2 points. Yeah, because that's what I need. Yeah, I think with points a segment is enough. So I have 3 segments, but I prefer to get 2 points. Yeah. So then what I know is that the slope with the one proportional slope is the BCD, which is this one, BCD. Yeah. And the biggest one is ACD. Yeah. So then I'm gonna make the parallel, which, sorry, I don't think we'll make it from here to there. Yes, so I'm gonna make a plane parallel to this one, BCD. Here I'm gonna make another one parallel to that one with the 2, and then another one on that side of the cone. Yes, yeah. So what I'm doing is that all these slopes, they have a same horizontal line, which is equal to the radius of that circle. Yes, of the radius of that circle. Yeah. So then, so what I'm doing now, I'm creating a slope here of ratio 1, a slope here of ratio 2, and a slope here of ratio 3, and I will make them parallels. So then if I double click again here, I need the horizontal line. Yes, so then I get a midpoint line from here to there, and this line needs to be tangent to this circle or perpendicular to this one. Yeah, I'm gonna make the same here. Perpendicular. Perpendicular to this one, or tangent will be the same. Yes, okay. And then, so then here I have, yeah, different slopes. Yeah, and then I can create here a plane. For example, this one, I can create a plane. I can create here another plane. And here another one. Yes. After, yeah. Okay, so I have 3 planes, and then I know that this plane have a ratio of 3 in 2 with this one, 3 in 1 with this one. Yes, and these 2 in 1 with this one. Why? Because they share the same horizontal, but the vertical is different. So here, if you have here a plot, for example, 1, 2, 3 with a slope BCD, so if the horizontal is the same in this case, BCD horizontal BCD is equal to horizontal ABD and to horizontal ACD, so they keep this ratio 1 to 3 with the verticals. Yes, and that's what I did. I have a vertical line that I don't know exactly the measure, but the horizontal are the same, but they keep this ratio. Yes. Okay, so then I have my slopes, but then I need to make sure that these slopes follow this ratio. So what I have to do now is to create here planes parallel to that ones. For example, I'm going to create this plane here. Why I cannot? It's quite slow today, this computer. Anyway, I create here a slope, a plane. Yeah. No, line 1 and line 2. Yes. Okay, and then I say that this one has to be parallel with this one. Yes, parallel. sometimes, yeah, maybe I made a mistake with this one. Yeah, because this one I cannot move it. Yeah, there's something here. I'm gonna make it tangent to this one. Okay, I'm gonna fix this point maybe. Okay, and let's try to do it now. If I cannot make it parallel, I can orientate it a bit more. No, why I cannot orientate it a bit more? Let me. Yeah, there is a mistake here. Tangent vertical. Yeah, this is the problem. Vertical. Yeah. Okay. Okay. See, I can move now the plane. Yeah. So what is going to do is going to orientate both planes to make them parallel. Yes. So this plane and that one, they are parallel. Yes. Perfect. You see, they are parallel. Okay. And then I'm gonna create another plane here between this one and that one. And then I make this plane parallel to this one. Control this one, parallel. You see, now it's orientating it, so they are parallel. This is 100, I don't know this measure, and then finally I need to make this final plane parallel. I need to create this one. I need to create this one. Seems a bit messy with many planes, but if you get a bit confused, you can put annotations with names of the planes. Yeah, and then this plane is parallel to this one. Okay, and now it's fixed, you see. And then, so if these planes have a ratio of 1, 2, and 3, and they are parallel, they keep the same ratio 1, 2, and 3, but with a given 100. So now they ask us, the question now is the slope of plane ABC. No, the slope of BCD, this slope, yes. So in order to know this slope, I only need to do, for example, to make sure that, for example, this radio, I can put it equal to 100. Yes, it's getting a bit too big, and maybe, yeah, it's a bit overlapping. I could move it in a different direction. Then I check this distance, and this 185.91. Yeah, which is this is not the solutions. Yeah. So yeah, this is 185.91. Yeah. Okay, so this is one method to solve it. I don't know if it is intuitive or not, but yeah, you see, we created the slopes here. equal, so with a proportion, then we make parallel. Yeah, but then I'm gonna make another solution which is not that intuitive maybe, but is maybe faster. Yeah, I'm gonna write solution 2. That is the same solution, but I'm gonna hide this one. Yeah, and we are gonna work with this. So similarly, I make the point D and yeah, I don't know exactly the thing, but what I know is that it is at the vertical height elevation of 100. So I can make the vertical elevation yeah, perpendicular to the plane, and the vertical distance 100. Yeah. Okay, and now I have to do the same. However, what I'm going to do is I'm going to do something a bit different. Yes, is that I wrote here the equations. Maybe, I don't know if they are very clear or not. Yeah. So I have these ratios between slopes, okay, 1, 2, and 3. Yeah, and what I did before is I keep this ratio 1, 2, and 3. However, I made constant the horizontal distance, and I made it 100. Yeah, that's what I did here in the solution 1. Yeah, here I put 100. I put different vertical elevations. Yeah, but now I'm gonna do something a bit different. So I will keep constant the vertical elevation with 100 for everyone, and then I will set ratios between horizontal distance. Yeah, so if this is, for example, if this slope is 3 times that one, yes, so this is equal to 3, so then the HACD in reality is 3 times HBCD, yes, and if this slope is 2 times that one, then that means that HABD, the horizontal distance, is 2 times the horizontal distance of BCD. You know, at the end we are using the thing, the definition that the slopes is a ratio between the vertical and the horizontal elevation. So this is what I'm going to do now. Yeah, so then if I have this thing, you know, I can create this slope here of this plane. I don't need even to create it. So this one is, I need to remember, ACD, yes. So the slope, so this line here is the line of interference between this plane and that one. Yeah, so if I create here a line between this line and the vertical elevation, and I make this one perpendicular to that one, that's how we measure the slopes or the angles. The angle between two planes is made with the lines perpendicular to the interference line. Yeah, okay, so I have this, so I could measure here the slope. Yeah, but as I set constant the vertical, I need to modify the horizontal to get the right ratio. Yeah, so I will do the same here. I'm gonna do the horizontal line for construction. And very important to make sure that these are perpendicular. this one and that one perpendicular. So I will have that slope here, that I forgot the names, but it is ABD, and I have to do here BCD. Yes, no surface, no line. Again, the horizontal, yeah, and this perpendicular. Okay, and then if we go to here, we need, for example, this is BCD and ACD. For example, the horizontal BCD and ACD is 3 times that one. Yes. So I mean 3 times this one is equal to 1 of these. Yes. So I can model it a bit and check, and that I can make 3 times this one and make one of these equal to one of those ones. Yeah. So then I go to the segmentation. So this is 3 times that one. So I go to segmentation. What is sketch tool, segment. I'm going to use now segment that they are better to make, and then I make that this one is equal to that one. Yeah, so this is 3 times that one. Yeah, yeah, I don't know if I put it here right, but yeah, this ACD is 3 times. Well, this one in reality is 3 times that one. That's the ratio. Yeah. And then this one here is 2 times that one. Yeah. So this one is 2 times that one. So now what I have to do here is to make another line. Now make it solid so I can use it, and this one I will sketch it in 2. Sketch segment 2, and then I put that this one and that one are equal. Yeah, and then I'm gonna get a compute. I always do with this to compute the slope. Okay, so then I need the meson of the horizontal one, which is from here to there, 53.79, and then I compute it here, which is 100, which is the vertical distance between 53.79, I think. Yeah. Yeah, and then I have the 1. Yeah, if I multiply by 100, it's 185.91, which is the same thing I got before. Yeah, so these 2 different methods to solve it. You just need to check the one that is more intuitive for you, or the easiest one. With this one we make the vertical constant, and with this just we create the slope, the different slope with the ratio, and make them parallel. So yeah, you choose which one you prefer, but the important thing at the end is to understand how to do the slopes, proportion, and how to create this construction. Okay, good luck trying to solve it.